for question 4, it's very scary, so I'm just going to start writing. It's a good way to get yourself to think is to start writing. So we know that we have a balloon that's 1 mile high. So here we have a little hot air balloon, and somebody is looking at something on the ground. Okay, let's be a flower in a pot. And this person, rather than looking straight ahead, looks down, and we have an angle of depression. So the angle below the vertical, the horizontal, is 35 degrees. And then after ascending means to go up, right? So we know that this is going to go up at a uniform rate for 10 minutes. He finds the angle of depression to the same object to be 50 degrees. So let me put that in. So person's now up here, and this becomes 50 degrees. And we're looking for the rate of ascent of the balloon in miles per hour. I have no idea what that is. But I know I can, if this is in miles, I can find this in miles. And what I'm considering then is if I'm going to find that, then I'm going to be using this little triangle. And I do know if this is 35 degrees, then this angle in the triangle is going to be 90 plus 35. So 125 degrees. And in fact, if this is 50, I have a right angle right here. So that's 40 degrees. So within this triangle, I have angle, side, angle. I can find a lot. The problem is I don't have a side in this. I mean, I have angle, side, angle, but I don't know a side. So in order to find a side, I'm going to have to determine, well, I'm going to determine this. And what I do know is that I have alternate interior angles. So again, geometry was important. So this is a 50-degree angle. And I do know that this side is 1 mile, so I'm going to find the hypotenuse there. So that's Q. So I'm going to say the sine of 50 degrees is the opposite over the hypotenuse. So then Q is going to be 1 divided by the sine of 50, which gives me, so I know Q is 1.305, right, and a lot more. I'm going to retain those numbers. And then within this triangle, I'm going to say X is 2, I need this little angle. So 125 plus 40, I've already used up 165 degrees, so this is 15 degrees. X over the sine of 15 degrees is equal to Q, 1.305, right, that whole thing, over the sine of 40 degrees. So I am going to take this number, 1.305, I'm going to multiply it by the sine of 15 degrees, and then I'm going to divide that by the sine of 40 degrees. And that's going to give me X is 0.5256. Okay, so that is the distance. So X has traveled that many miles. That many miles, 5256 miles in the course of, let's talk rate, miles per 10 minutes. But I don't need miles per minute, I want miles per hour. So I'm going to multiply by 1, and I want to cancel out minutes. I know 60 minutes is equal to 1 hour. So here I am really multiplying by 1, but I'm canceling out the minute unit. And then 10 goes into 10 once, 10 goes into 6 times. So in miles per hour, I just need to take this number and multiply by 6. So this is traveling at a rate of 3.154 miles per hour.